Welcome back, ladies and gentlemen, to day 2 of two-stepping equations, the exception to the rule. Yesterday, we talked about the steps for solving a two-step equation. And as always, the first step was to write the equation down. Next, we decided that we should undo any addition or subtraction first by showing the inverse operation under both sides. Our third step was to undo any multiplication or division by showing the inverse operation on both sides of the equation. Well, that's all well and good, except the exception to the rule. And here's what I'm talking about. If the addition or subtraction is taking place above the division bar, in that case, undo the division first and then the addition or subtraction. Let's take a look at what that would look like. Both these equations have addition or subtraction in them, and then they both have division. But if you notice, in this case, the addition and subtraction is above the division bar and the whole thing is being divided. In that case, we've got to undo the division first. So what this would look like is, since on the left-hand side it says c minus 5 divided by 4 is equal to 3. Well, since they're dividing c minus 5 by 4, we have to undo that before we can do anything else. So we're going to multiply both sides by 4. When we do so, these 4's will cancel out, and it will leave us with c minus 5 is equal to 12. Now the only thing they're doing to c is subtracting 5. To undo that, we're going to add 5 to both sides of the equation. When we do so, subtract 5, add 5, nothing really took place, so c is isolated. And our solution would be c is equal to 17. If we plug that in to check it, if we plug the 17 in for the c, we would have 17 minus 5, which is 12, and 12 divided by 4, which is 3. And we end up with the true statement, 3 is equal to 3. On the right-hand side, we've got the sum of b and 1 divided by 3. Since the addition is taken above a place above the division bar, we've got to undo the division first. So we need to multiply both sides by 3. When we do so, we're going to get b plus 1 by itself, and on the other side, we will have 6. So we're left with b plus 1 is equal to 6. The only thing they're doing to the variable now is adding 1. We know that the inverse operation of adding 1 is subtracting 1, so we'll subtract 1 from both sides. When we do so, b plus 1 minus 1, we're back at b, and b's isolated now. 6 minus 1 is 5, so our solution to this would be b is equal to 5. To check it, we can plug 5 in for the letter b, the variable b, and just simplify that side. So 5 plus 1 is 6. 6 divided by 3 is 2. And we end up with the true statement, 2 is equal to 2. All right, ladies and gentlemen, now you know the exception to the rule.